Okay, next we move to the compression ratio. And increasing in compression ratio increase the thermal efficiency. So it's important if we have a good compression ratio to gain more thermal efficiency. The compression ratio is most spark ignition engines is limited by knock and use of economical feasible anti-knock quality of fuels. So knocking is where the combustion is not perfect. There's some parts of the fuel mixture is not burning. That is we call knocking. An increasing of compression ratio also increase the friction of the engine. So particularly between piston ring and the cylinder walls. And there is a point at which further increase in compression ratio will not be profitable. So there's a limitation of compression ratio value. In the compression ratio in internal combustion engine, that is represent the ratio of the volume of its combustion chamber. So from its largest capacity to a piston engine, ratio between volume of the cylinder and combustion chamber, volume of the cylinder and combustion chamber when piston is at the bottom of BDC of its stroke, and the volume of combustion chamber at the piston at the top or TDC of its stroke. Picture cylinder and combustion chamber with the piston at bottom containing of 1000 cc of air, 900 plus 100 cc of combustion chamber. So when the piston moves to the top of its stroke inside the cylinder, the remaining volume inside the head and combustion chamber has been reduced to 100 cc. So 900 and 100 cc, then the compression ratio would be proportional as described as 1000 per 100, or the fraction reduction of 10 to 1 compression ratio. High compression ratio is desirable because it allows an engine to extract more mechanical energy from given mass of air fuel mixture due to high thermal efficiency. But high ratio place the available oxygen and fuel molecules into the reduced space along with a adiabatic heat of compression, causing better mixing and evaporation of fuel droplets. Thus, they allow increase of power at the moment of ignition and extraction of more useful work from the power by expanding the hot gas to a greater degree. So higher compression ratio will however make gasoline engine subject to engine knocking. So this is not good. If lower octane rated fuel is used, also known as detonation. So octane fuel ni you can see as in RON 95 and 97 is different. So this can reduce efficiency and damage the engine if knock sensor are not present. So usually normal engine they don't have knock sensor. So if your compression ratio is not good, you might have the possibility of engine knocking. So meaning that some of the fuel is not burning. And this, if you have a knock sensor, then this will timing your spark ignition to produce a spark in a way to have a full combustion. So however, knock sensor have been required. It's a requirement of OBD2, especially used in 1996 for model year vehicles and newer. So from 1996 onwards, The knock sensor is quite common in every vehicle. Okay, here we can see some of the passenger car characteristic. The BMEP and the maximum torque, maximum power. You can see between this is quite an old car, but some of it is a high performance car. This L is linear engine, V is V-type engine. So you can see here V-type engine usually have higher torque and higher. So this one displacement, the liter. So this 3.0, the biggest one is Lamborghini 5.71. It have about maximum horsepower 492 horsepower per at 7,000 rpm. Torque is 427 pound per feet at 5,200 rpm. Okay, just you can see the difference between 2-liter car and 5-liter car. Okay, how to improve engine performance? There's two general areas to improve the engine performance. First, energy put into the engine at the start may be increased by energy supply, may be increasing the mass of charge entering the combustion chamber, and supercharging is one method of accomplishing it. Another way is larger piston displacement is another solution, but it is limited to engine weight and cooling problems. And then improvement of volumetric efficiency also increase the mass of charge. And higher engine speed may be utilized, but this is an increase of friction loss, and above a certain point in lowered volume it can lower the volumetric efficiency. So the efficiency with each the fuel energy is converted to mechanical energy will increase. First of all, you have to improve fuel, resulting greater usable energy content without detonation also help. And the use of high compression ratio will increase the efficiency of conversion of energy in the fuel into useful mechanical energy. And also the required of development of economical, feasible, higher anti-knock quality fuel. So this one is all about fuel. This one fuel, and this one compression ratio, quality fuels, improvement of fuel resulting greater usable energy. So this one also about the fuel improvement. So another way would be to reduce the losses between air cycle and actual cycle, and thereby increase the proportion of energy which can be mechanically utilized. Also, it is possible to take advantage of kinetic energy in the exhaust gas to increase the engine output through use of exhaust driven turbines. So this is what being done in Formula 1 cars. They are using the exhaust driven turbines. In this case, the exhaust gas from engine cylinders drive a turbine, and it connected to the engine crankshaft, thus increase the engine output. How it increase the engine output? By giving higher pressure to inlet air and fuel mixture. So they're using the power from exhaust gas to produce more pressure to inlet gas. So engine having this type of power booster is known as turbo compound engine. So there's more and more car recently have turbo because they want to produce more energy or more power to the engine. So sometimes they call it as downsizing, smaller size of engine but have bigger engine performance. For example, if you use turbo 1.6 engine turbo, and it can be almost similar to 2-liter engine without turbo. So it gives more power with a smaller engine.